Good evening. Welcome to Learn Certified Cybersecurity Class 4. Today, um, so I do hope we all have been able to go through the recording for the last weekend's class. I believe you all got it and you have been able to go through or to listen to it or watch it rather. So yeah, so we stopped last week talking about the Wayback Machine. And I was saying that I was going to tell us more about this machine today. So I want to let's take a look at that's the website address is archive.o.org. So for instance, now I want to search for, Punch. All right, so you can see it has taken screenshots of different dates. I want to see 20, 2023, 2019. Okay, let's check for 2019. Let's check for May 29. Okay, this is 2019. Okay, let me get 2019 May 30th. So it takes snapshots of websites. So if an attacker wants to look at, he has a target website in mind and he now wants to uh, uh, look at maybe something that the owner of the website or the target company has taken down. Maybe they have removed it from their web page and he wants to go back and check that thing. He needs that information for a particular purpose. Then what he does is to use this Wayback Machine. So you can see that on this, I wanted to check, this was May 30th. So that was the second swearing for second term for Buhari. Buhari's inauguration, PDP orders knock president for keeping mum, Obasanjo Jonathan absent. So the inauguration takes place. I mean, it took place rather on May 29, but this is the newspaper for May 30th that recorded it. So you can use it for any website you so desire. Okay. So other techniques for website footprinting. Remember, we're still talking about footprinting, gathering information for a target from the website of the of the website of the target. So other techniques: extracting website links, description, analyze the target website to determine its internal and external links. Information gather linked images, scripts, iframes, and URLs of the target website. Tools that are used: AutoPass, NetSpeak, Spider, and Link Extractor. So those are tools that can be used. Then gathering word lists from target website. You gather word lists available on the target website will first the email addresses gathered through search engines, social networking sites, website. So the information you gather through this is the list of words from target websites. You can use CEWL, the tool, to do that. Then extracting metadata. It allows you to have title of page, description, keywords, creation, stroke modification, date and time of the content, usernames and email addresses of employees of the target organization. So EXIF to web data extractor and MetaGoofio. Then monitoring web pages for updates and changes. You can detect changes or updates on the target website. You can get information about changes to the login pages, password protected pages, software version, and driver updates and images. Tools that you can use: website watcher, visual ping, and follow that page. Then searching for contact information, email addresses, and telephone numbers from company websites. The information you gather is for you gather contact details, location, partner information, news, and links to other sites. So searching for web pages, posting patterns, and revision number. You want to know their posting patterns and revision numbers. Search for copyright notices and revision numbers on the web. So things you can get include copyright symbol, year of the creation of the website, name of the author, and a right statement you can get through web search. Then monitoring website traffic. You want to know how many people view or visit the website. You can get that. The kind of information you can get is total visitor, page views, bounce rate, live visitor map, site ranking, and customer location, web start, rank tracker, team viewer, and also Alexa. Alexa is a source of information in that regard. Okay, so we have for extracting website links, AutoPass. Um, AutoPass offers automatic data extraction as it quickly scrapes web data without coding and turns web pages into structured data. So you can see AutoPass, autopass.com, autopass.com. And when you search for it, it looks for different forms of data. You want to extract backlinks to a target website, which can provide information about the target. So AutoPass. Want to look at linked images, scripts, iframes, and URLs of the target website. We use AutoPass. To gather word lists from the target website. So we want to gather as many words as possible so that you can use it to brute force email addresses and all that. So you can run CWL2. CWL2. So this tool is on Parrot. I will get the link across tomorrow. I will prepare for that tomorrow so that we can see about how to get Parrot installed. So there you have all the tools, but I'll get it across tomorrow. Then extracting metadata extraction to have exif 2, the cross-platform Perl library and command line application for reading, writing, and editing metadata and files. Supports a large number of metadata formats, including EXIF, HTML, GPS, IPTC, XMP, and JFIL. Allows coupling metadata between files of different formats. It helps in extracting thumbnail images, preview images, and large JPEG images from RAW files, so EXIF2 or TXE. It's a command line tool. Then monitoring for website changes. If there are changes, you have website watcher, aignes.com, aignes.com. It helps to track website for updates and automatic changes. So when such dates occur, it automatically detects and saves last two versions onto your disk. So website watcher. You want to search for different information like contact number, company contact number, company location, partner information. You do that on the website. You want to search for web pages, posting pattern, revision numbers. You go to what's it called? You go to the website itself. Then to monitor website traffic, you have different tools. So clicky.com, that helps you to find the number of visitors browsing the target website. Page views, tools such as Open Tracker can monitor the total number of pages viewed, number of pages viewed by the users, along with timestamps. Bounce rates, tools such as Google Analytics measure the bounce rate of the target company's website. Live visitors map, tools such as WebStats track the geographical location of the users visiting the company's website. Site ranking, tools such as Rank Tracker track a company's rank on the web page. Audience geography, they track customers' location on the globe, and going up, track visitors, monitor sales, and show conversation rates with the company's website. So clicky.com. Okay. It's a paid service. Allows you to monitor. Let me see, going up. So goingup.com. Okay, it's also a signed service. So, but basically, what they do is that they allow you to monitor a website to know about the traffic and the other things. You don't want to know the number of visitors that are visiting the website, among other details. So then we move on to, we have talked about the website. We want to talk about tracking email communications. Tracking email communications. Email tracking is used to monitor the delivery of emails to an intended recipient. So attackers track emails to gather information about a target recipient, such as IP addresses, geolocation, browser and operating system details, to build a hacking strategy and perform social engineering and other attacks. So the kind of information we can get include recipient system IP address, the person that receives the email, the IP address. So, but before we go on to that, the tools we can use: Email Tracker Pro, Infoga, and Mail Track. So, geolocation, you can be able to at least estimate the person's location. The email received and read notifies the attacker when the email is received and read by the recipient. The read duration, that's the time the person used in reading the email. Then proxy detection provides information about the type of server used by the recipient. Then links, whether links sent to the recipient was checked. Then operating system and browser information reveals information about the operating system and the browser used by the recipient. So all this information can be obtained. Okay, the other ones: forward email, whether the person sent it to you, forwarded it to another user, the type of device the person used, the path traveled. So have different email clients that are normally email programs that are usually used to read emails. So, but the main information we can get it from the email header. We can get the sender's email server. The email header is this. This is a sample of an email header. This is a sample of an email header. So you can see the address from which the message was sent, the sender's IP address. It is an IP version 6 address. Then the date and time you see by the originator's email address, the sender's mail server, the authentication system that was used, the sender's full name, then the date and time of message sent will be there. So email tracking tools, we have Email Tracker Pro, Infoga, Mail Tracker Pro, Lightmail. It allows an attacker to track an email and extract information such as sender identity, mail server, sender's IP address, and location. So email tracker Pro analyzes email orders and reviews information such as sender's geographical location and IP address. So I have email tracker. Let me see. Infoga. You can get this from Git or GIT HUB. It's a tool used for gathering email account information, IP hostname, country from different public sources, search engines, PGP, and should I check if an email was leaked using the have I been pwned.com API. For example, the command python infoga.py domain microsoft.com source or breach microsoft.l retrieve all publicly available email addresses related to the domain microsoft.com along with email account information. So that's what it is. You get some emails that are related. Then this email tracker pro allows you to analyze email headers and extract information so that senders geographical location, IP address, and so on. It allows an attacker to review the traces later by saving past traces. So email tracker pro. Then when we want to get information about a website or the owner of a website, we'll gather information from WHOIS. We call it WHOIS lookup. WHOIS databases are determined by regional internet registries and contain personal information of domain owners. So when you register a website, you submit all manner of information. You understand? So when you submit all manner of information concerning that particular website, what happens is that it's stored somewhere. So by the time somebody goes and tries to run a query on the WHOIS information, it will be supplied to the person. It will be supplied to the person. So, but we have regional registries. We have regional registries, and these regional registries cater for each continent. They cater for each continent. Um, like Africa is Afrinic. Then Europe, RIPNCC. Then Latin America and Caribbean countries, LACNIC. Then Asia Pacific, APNIC. Then ARNIN is for American, North America. So what are the WHOIS query returns? You have the domain name details, contact details of domain owners, domain name servers, net range, when a domain was created, expiry record, last updated record, information obtained from WHOIS database, assists an attacker to gather personal information that assists in social engineering. Because before, there used to be a lot of information. You get the technical support, will drop his details, all manner of things. All manner of information will be dropped. So with that, the anybody that wants to do social engineering to manipulate somebody to give some details, you will have enough things to work on. You have enough details to work on. So net when a domain was created, expiry records, last updated record, then gather information that can be obtained from WHOIS database, assist an attacker to gather personal information that assists in social engineering, create a map of the target organization's network, obtain internal details of the target network. So let's look at an example. Um, okay, WHOIS is a query and response protocol used for querying databases that store the registered user or assignees of an internet resource, such as domain name, an IP address block, or an autonomous system. The protocol listens to requests on port 43. Regional internet registries maintain WHOIS databases which contain the personal information of domain owners. For each resource, the WHOIS database provides text records with information about the resource itself and relevant information regarding assignments, registrants, and administrative information. So we have tick WHOIS, which contains complete WHOIS information from register team, stores only the name of the WHOIS server of the register, which in turn holds complete details on the data being logged up. So it usually contains domain name details, contact details of domain owner, domain name servers, net range, when a domain was created, expiry records, and so on. I'll talk about the different registers. So we have whois.domaintools.com. You can perform WHOIS there. So let's check it out. Okay, so if you want to check, for instance, um, Microsoft.com. So um, you can see the record for Microsoft.com. It was created in 1991, the 2nd of May 1991. It's expiring 2025. So of course, before it expires, they will renew it again. So I have the different name servers, then the IP address, the location, Washington, Seattle, Akamai Technologies, ASN, registered and no website, IP address, 562 IP history, changes on 562 unique IP address over 20 years, register to 4 registrars with 2 drops, hosting history, 3 changes on unique name servers over 4 years. So we have the WIS record, domain name, the registry, macmonitor.com. It was so. So that's basically the so this is the IP address. Like I said before, the computers don't communicate in words, they communicate in numbers. So that's the IP address for Microsoft.com. Of course, there are other IP addresses that are also associated with it. So, but like we said, a lot of information is not being released in previous. Let me even see the kind of information we're able to get. Okay, let me see which address are they even searching for here. Let me check so we can check it also. Ah, okay, certifiedhacker.com. Okay, let me check for that. Certified hacker. Okay, it was created 2002. Wow, that's a long time ago. Certifiedhacker.com. Network solution. 162.241.216. 16. Okay, still the same IP address. So the location, it gives you the Utah. Utah. So the other places also you can check. Smart Wiz. Smart Wiz is a tool, but what you get on what's it called? What you get on that wiz.domaintools.com is also what you will also um, get on what's it called? Smart Wiz. On Smart Wiz. Like finding IP geolocation information, IP geolocation helps to identify information such as country, region, state, city, zip, postcode, time zone, connection speed, and so on and so forth. So if you want to find a particular IP address and you want to know the location of that particular IP address, the geographical location, you can use IP to location. IP to location. So IP to location.com, you can use it to find if you have an IP address like this one, IP to location.com. So you can try to look up an IP address. Let's see. Let's look up this IP address. So you can see it correlates with what we have here, Utah. Utah. So we're looking for the location Utah. Provo. Provo. Utah Provo. So coordinates of the city, ISP infra layer, mobile station, elevation, data centers, America, Denver, and so on and so forth. Okay, let's run along now. Okay, different techniques for DNS. Like DNS is what resolves the system that resolves domain names to IP addresses. Resolves domain names to IP addresses. Attackers perform DNS frequently to gather information about DNS servers, DNS records, and the types of servers used by the target organization. It helps attackers identify the hosts connected in the target network and further exploit the target organization. This session describes how you can extract DNS information and perform reverse DNS lookup. So you can extract DNS information. We have different types of DNS records that pertain to particular website. We have A record. That is the host IP address. MX is the domain's mail server. NS is the host name server. CNAME is the canonical naming. Then source of authority, indicate authority for a domain. SRV, service records. PTR maps IP address to a host name. That's if you want to do reverse lookup. Normal lookup is for you to put a host name like certified at arca.com, and it will give you the IP address. But when you use PTR, it now does reverse local. Then RP responsible person, H info, host information, TXT, unstructured text records. So attackers query DNS servers using DNS interrogation tools such as security trails, NS lookup, DNS records to retrieve record information that contains information about the target DNS. So use that to check security trails. Security trails, we want to use it to search security trails. So certified. Okay, so we have the A record, the mail server, MX source of authority, canonical name, text, NS name server, A records, no records. So these are the record. And does it have any historical data? So it wants us to log in for that information. So these are just the basic information you want to find out. As you can see here, we have the AA records, but this particular account here is not a free account. So it's giving a lot more information than the one we used. So you can do reverse DNS lookup if you have an IP address and you want to find out what is the domain name associated with that particular IP address. You can do a reverse lookup, DNS lookup. So to locate a DNS PTR record for those IP attackers use tools such as DNS Recon and reverse lookup to perform the reverse DNS. So you can use DNS Recon and reverse lookup. So DNS Recon does the same thing. So you can look at mxtoolbox.com. MX Toolbox. You can just input the what's it called IP address, and it will be able to show you the name. It's now telling this particular, I said bluehost.com. Okay, we can also footprint the network. We have talked about website footprinting, email footprinting, DNS. Now I want to talk about the network. So network range information assists attackers in creating a map of the target network. Attackers want to know the network range of a particular uh, target website. One can find the IP range of IP address using ARIN. You can use ARIN, WHOIS databases search tool. One can also find the range of IP address and the subnet mask used by the organization from registry internet regional internet registry. Because what we want to do, we want to know how many, when the attacker gets the network range, it allows him to have a map of organization. So if he wants to now do, by the time we move to scanning, we are scanning for systems, scanning for ports. It will allow the attacker to know, okay, this is the network range that has been assigned to this particular organization. They will now enter the network range in the, what's it called, the tool he wants to use to scan, and now use it to, he will run it, and that will give him a good idea. So that will give him a good idea of how many network, I mean, how many devices are within the system, I mean, within that particular network. So that's the advantage of that, getting the network range. So using the network range, an attacker can obtain information about how the network is structured and which machines in the network are alive. So it helps to identify the network topology, access control device, operating system used in the target network. To find the network range, the target network, I mean, of the target, one must enter the server IP address gathered in WHOIS fingerprinting in ARIN WHOIS database search tool. The user can also visit ARIN website, arin.net, and enter the server IP into the search WHOIS text box. This is the network range of the target network. In properly set up DNS server, offer attackers a good chance of obtaining a list of internal machines in the network. Additionally, if an attacker traces a route to a machine, it could be possible to obtain the internal IP addresses of the gateway, which can be useful. So we see arin.net. So we have arin.net. Okay. So let me confirm something. Okay, so let me see. Okay, we have an IP address. I think there's an IP address here. Is this copyable? Okay. All right. So you can see that the net range for this particular IP address is 162.240.0.0.0 to 162.241.255.255. So that's the range. It gives us, so you can see again that it's Provo, Utah. That's the registrant for certifiedhacker.com. So they have a range that they are being given. So so this would they search for, I think this is Microsoft, yeah. So look at the address range 207.46.0.0 dot to 207.46.255.255. So they queried with a particular IP address and give them this particular range. So also we can do trace route. Trace route is what you use to check the path which the packet travels from your device to a target device. You use it to look at to know the routers on the path to target host. So if, for instance, we're in Nigeria now, you want to visit CNN.com, don't think that from your computer directly to CNN.com, you'll be surprised that it passes in between, maybe it depends on the network, it may pass as much as 15 or even up to 30 routers before it gets to CNN.com. So you can do that. You can check, you can use this method on your, you can even use google.com. If you are using Windows system, you just go press 3sat, either google.com or this IP at the 216.239.36.10, and it should show you how many ops it has to pass. You can see this one 13, just 13 ops before it gets to where it is going. Then for trace route analysis, I don't know. Let me see. I let me see if I can. Okay, I think there's a tool I saw. Hmm. This one is not going. Probably the network. Let's say maybe google.com. So what we want to do is to find out um how many ops. Uh, sorry, I have to change this. Does it have Nigeria? The tool I'm used to, it didn't load. Let me check this. Okay. Um, Google.com that loads very fast. You want to see, okay. Which one is this one? I don't know why. Well, let me see. Maybe I have to use my terminal. Let me use my terminal. Only that you may not see it very well. Trace routes because I'm using MacBook. So um, okay, okay. So it started the whole process now. It will start tracing from one um, up to the other. So you can also try it on your own. All these things I've done, you can do it on your own. When you get the recording, start just check it on your own. Look at the website we have looked at, and even other things you may see in the material. So you can see this Google that opens within seconds. You can see number one, they gave me the IP address, then the different ops it has to pass through before it gets to the location. So okay, so let me quickly. So how do you do the analysis? And attackers execute trace route to find IP addresses of intermediate devices. Just as I've done. Yeah, I've been able to find out in intermediate devices that are in between myself. Oh, it is cleaned off. So which up is it? These are the, is like you the attacker is trying to look at the map to get the topology of the network that he wants to get into. So he gets the intermediate device between himself and the target website or target IP addresses. So attacker might obtain the following information: trace route one, second to the last hop is 10 is 1.10.10.1. Third to last 1.10.10.1. So with that, you'll be able to identify. Look at what it does here. This is the internet. This is the router. The second to the last. The 10.10.20. This is the third to the last. 10.10.50. That's um second or third to the last, then and so on and so forth. So it's able to get the topology of the network that way. We have tools for trace routing. You can use online tools. You can as well use Path Analyzer Pro. It will give you just like what you got in your terminal. Do it's more the result is more dynamic and also visual route. It makes it graphical. You can see it here. This is a bigger screenshot. Um, Packet Analyzer, Path Analyzer Pro, then visual route. We make it even very visual for you. Then you can do footprinting to social engineering. I will not be delving much into this because we'll still be dealing with social engineering in some weeks to come. It's a whole module on its own. So the basis of social engineering is that you want to manipulate people to give you information that they should keep confidential. So example of social engineering that we see a lot now is when people do this WhatsApp hijacking. WhatsApp hijacking, they call you, ask you to give them a code, and that code they are giving is what they will use to hijack your WhatsApp. Then we have people that claim to be bankers. They claim to be bankers, and They call you, give you some correct details, maybe your account number, your BVN number, your date of birth, and ask you for maybe ATM card number or details or that CV2 or whatever. So, and they do it to gather credit card details, username and password, security products in use, operating system and software versions. That they want to know those. They want to know network layout. They also want to have IP address and name of server. So social engineering techniques include eavesdropping, shoulder surfing, dumpster diving, impersonation. So for eavesdropping, just listening of someone's conversation, authorized listening of conversation or reading of message, interception of any form of communication such as audio, video, or text. Then shoulder surfing, secretly observing the target to gather critical information such as passwords, personal identification number, account number, and credit card information. So that is um, shoulder surfing. Shoulder surfing. Secretly observing target to gather critical information such as passwords. So that used to happen a lot in ATM booth. So where people will position themselves to see what your ATM pin that you are trying to enter. Also, when you are trying to enter your pin to access your phone, some people will also want to watch and see, look over your shoulders and see what they are trying to enter. Then also dumpster diving is when people throw away trash and other people come to look through it, to check through it, to try and get relevant information. Maybe their phone bills, contact information, financial for the impersonation is pretending to be legitimate or authorized person. So that's then for that we have footprinting tools, fingerprint organizations with collected archives, a tool used mainly to find metadata and hidden information in the document it scans. So also OSR framework includes applications related to username checking, DNS lookup, information leaks research, deep web search, regular expressions extraction, etc. So attackers search for target user on social media platforms. So they can use this to search for a particular person that they want to know. They can use it to search. Like this person, they are searching for Tim Cook. Tim Cook. So um, we have Recon Dog. All the one to for information gathering needs. We use API to collect information about targets, system, then build cipher, information gathering tool for a website or IP address. Build cipher. Other tools we have spies. Use different parameters available in the tool to identify information such as subdomains, certificates, and vulnerability risk scores. I think it's a paid spies. Wow, maybe it's no longer. I checked it. It's, it's no longer available. I think maybe they stopped working. Grecon, the adversary, the three inspector, Raccoon, Ob. Can use Multigo. Multigo can, once you drop somebody's name, it will use it to extract different information from different parts of the internet. So So it will get information about that person from all aspects of the internet. Then recon, web reconnaissance framework with the independent modules for database interaction that provides environment in which open source web-based reconnaissance can be conducted. So attackers use module recon domains host boot host to extract a list of hosts associated with the target URL. So you can get different hosts that are associated with a particular URL. Yes. What are countermeasures if you are the cybersecurity analyst in charge of an organization? What are the countermeasures you can put in place against footprinting? You restrict your employees' access to social networking sites from the organization's network. Don't allow them to visit um, social networking sites from the corporate network organization. Configure web servers to avoid information leakage. Educate employees to use pseudonyms on blogs, groups, and forums. Let them not use their real names because there are tools that can just enter the person's name and it will pull it out, pull the person's account from all over the internet. Then do not reveal critical information in press releases, annual report, product catalog. So these are sources of information for attackers. Limit the amount of information published on a website or the internet. Use footprinting techniques to discover and remove any sensitive information that is publicly available. Then prevent search engines from catching a web page and use anonymous registration services so that they don't. If I perform weeks concerning your organization, I will not be able to get um, details about it. Develop and enforce other countermeasures. Develop and enforce security policies to regulate information employees can reveal to third parties. Set apart internal and external DNS or use split DNS and restrict zone transfer to authorized servers. Disable directory listings in web servers. Conduct security awareness training periodically to educate employees. Offer privacy services on who is lookup database. So avoid domain level cross-linking for critical assets, encrypt and password protect sensitive information. Place critical documents such as business plans and proprietary documents offline. Don't put it online where somebody can be able to get trained employees to track social engineering techniques and attacks. Sanitize details provided to internet registrars to hide direct contact details of the organization. Disable geotagging functionality on cameras to prevent geolocation tracking. Avoid revealing one's location on traffic lanes on social networking sites. Turn off geolocation access on non-mobile devices when not required. So many of us like to leave on our location on our phones. It's not really advisable. Ensure that no critical information is displayed on notice boards or walls. So I think that's what so that we can move to uh, another. So before we round off for today, scanning networks. So this scanning networks is about scanning the target. Now remember, well, we were able to get network block from our reconnaissance. So the information we got obtained when we're doing reconnaissance is what we'll now use to make further moves by scanning. So we are scanning for systems that are reachable. We are scanning for ports on those systems. Remember, I said that ports are like windows or doors into a building. So the same way ports like doors or windows into a system. So, but on those doors and windows, there are what we call services that run. So, and each service has its own vulnerability. So, apart from that, we also scan to discover the operating system that is running. If we have not been able to obtain that information, the cost of our reconnaissance or footprint. So, we obtain the operating system that is running on the system, on the targeted system. So, um, footprinting reconnaissance mode, attackers begin to search for an entry point into the target system. Attackers should determine whether the target system are active or inactive to reduce time spent on scanning. Notably, the scanning itself is not the actual intrusion, but an extended form of reconnaissance in which the attacker learns more about his or her targets. Information gleaned from such reconnaissance helps the attacker select strategies for attacking the target system. So, we are starting with an overview of network scanning and provide insight into various host discovery techniques that can be used to check for live and active systems. So it's expected that at the end of this module, you should be able to describe network scanning concept, use various scanning tools, perform host discovery to check for live system, perform port and service discovery using various scanning techniques, perform operating system discovery, scan beyond intrusion detection systems and firewalls to explain various network scanning countermeasures. So overview of network scanning. This refers to a set of procedures used for identifying hosts, ports, and services in a network. So network scanning is one of the components of intelligence gathering, which can be used by an attacker to create a profile of the target organization. So network scanning process, the attacker sends TCP IP probes and it now gets network information from the network. So what are the things we want to objectives of network scanning? Discover live hosts, IP addresses and open ports of live hosts. Discover operating systems and system architecture. Discover services running on hosts. Discover vulnerabilities in live hosts. We have different types of we have port scanning, like I said, network scanning, vulnerability scanning. So these are the three types of scanning we have. Port scanning, you scan for open ports. Network scanning, you list the active host and IP address. And the vulnerability scanning shows the presence of known weaknesses. So, so if you are asked about the three types of scanning, we have uh, those are those are the three types of scanning: port scanning, network scanning, and vulnerability scanning. So TCP communication flag. Now, when we talk about um, how do I put it? There's a way that computers communicate. They will call it the open system interconnectivity, open system that OSI model. And it has 7 layers. I think I've mentioned that information earlier on. It has this first layer, which is the physical layer, where we talk about cables, connections using cables and all that. Then we'll move to the second layer, which is data link layer. Then we'll move to um, transport. Okay, the first layer is application. Sorry, layer 7 is application. Layer 6 is presentation. Layer 5 is session. Layer 4 is transport. Layer 5. No, sorry. No, I've messed it up. Let me go back again. Layer 7, which is the topmost layer, is application. It deals with all the applications we use like HTTP, HTTPS, then majorly the applications that we use. I mean, to access different, like even your web browser. Your web browser is like an application. Now we now talk about presentation. The presentation, then that's layer 6. Then layer 5 is session. So then layer 4 is transport. Layer 3 is network. Layer 2 is data link, while layer 1 is physical. Please mute your mic. Please do not unmute your mic. Thank you. So, all right. So now at the layer 4, layer 4, where the communication, we call it segments. There are two protocols that work at that layer. They are the TCP and UDP. TCP is transmission control protocol, while UDP is user datagram protocol. Now, for TCP, the way it does its own communication is that it's what we call reliable uh, connection oriented protocol. Why? Because before it establishes any communication between two devices, there's a check. It checks whether that device is available. But for user datagram protocol, we call it connectionless and unreliable because it just sends, it doesn't ask that the other person is available. So you know that TCP, we have what we call um, three-way handshake. Three-way handshake, and that three-way handshake is it occurs in this way: the person that initiates, or the service or the client or whoever that initiates the connection, will send a flag. So now we have 6 TCP flags, as you can see on the screen. Now we have URG, which means urgent. That is, the packet should be processed immediately. Then finish means that the termination of transmission. There is no other thing that will come for there will be no other transmission. Then RST means to reset the connection. Then PSH sends all buffer data immediately. That's push, sends all buffer data immediately. ACK acknowledges the receipt of a packet. Then SYN, synchronize, initiates connection between hosts. So we have URG, FIN, RST, PSH. Push sends all buffer data immediately. ACK acknowledges the receipt of a packet. SYN, synchronize, initiates connection. So SYN is what is usually sent by somebody who wants to initiate a connection. He sends that thing, and the recipient will now respond with SYN stroke ACK, which is its own synchronize and also acknowledge the synchronize that was sent earlier on. So finally, the client will respond with ACK. So which means the three-way handshake. Three-way handshake. So that's what makes the connection to be established. So we have talked about the TCP communication flags. So we have, in every packet that is sent, we have the source port. It will indicate the source port and also the destination port, the sequence number of that packet, the acknowledgement number, offset, RES, TCP flag. Will it be FIN, URG, PSH, SCK? The flag, the window, the TCP checksum, urgent pointer, and options. So the 6 TCP control flags manage the connection between hosts and give instructions to the system. Four of these flags govern the establishment. This SYN, ACK, FIN, and RSC govern the establishment, maintenance, and termination of a connection. The two other flags, PSH and URG, provide instruction to the system. The size of each flag is 1 bit. As there are 6 flags in the TCP flag session, the size of this session is 6 bits. When the flag is value is set to 1, that flag is automatically turned on. So these are the TCP flags. Okay, so we have synchronized or SYN. Okay, I think, okay, let's just go through this. So synchronized or SYN notifies the transmission of a new sequence number. This flag generally represents establishment of a connection. That's three-way handshake between the two hosts. Like I said before, that's the first that goes. Then acknowledgement or ACK confirms the receipt of the transmission and identifies the next expected sequence number. So when the system successfully receives a packet, it sets the value of its flag to 1, thus implying that the receiver should pay attention to it. So PSH is when it is set to 1, indicates that the sender has raised the push operation to the receiver, that the remote station should inform the receiving application about the buffer data coming from the sender. It raises the BSH flag at start and end of data and sets it to last segment of a file to prevent buffer deadlock. So PSH, that is push buffered data to process it. Then urgent is so designed to process the data contained in packets as soon as possible. When the system sets the flag to 1, priority is given to processing the urgent data first, and all the other data processing is stopped. So that particular data is processed first. The FIN is set to 1 to announce that no more transmissions will be sent to the remote system. The connection established by the SYN flag is terminated. RST, when there is an error in the current connection, this flag is set to 1. Now the connection is aborted in response to the error. So attackers use this flag to scan hosts and identify open ports. So this is the three-way handshake I was indicating earlier on. This is the session establishment. So you see SYN is sent first. SYN plus ACK, then ACK. Then if you want to terminate, you send FIN, it will now send ACK, then FIN, then ACK will come third, last. So that's three-way handshake. So we have tools to scan, various networking tools. We have Nmap, Nmap2. So these two network administrators use it for inventorying a network, managing service upgrade schedules, and monitoring host or service uptime. Attackers use it to extract information such as live hosts on the network, open ports, services, application name and version, types of packets, filters, and firewalls, as well as operating systems. So you can see the different information it gives. It can give information about live hosts on the network. It can give information about open ports or services, and also types of packet filters. That's when we're talking about packet filter, we're talking about firewalls. Firewalls. They are the same thing, only that the packet filters are more software based. So then as well as the operating system and the version that is being used. So we have different commands. Okay. We have mmap. So you can download it from mmap.org. mmap.org. Then we have other tools to scan. This is command line interface tools. HPing3 can be used for security auditing, firewall testing, manual path, MTU discovery, advanced trace route, remote operating system fingerprinting, remote uptime guessing, TCP/IP stacks, auditing, etc. So if you want to do ICMP scanning, um, HPing3, we're going to get okay, ICMP scanning, HPing3, then the target IP address to do IP scanning, then ACK scan on port 80. If you want to scan for ACK scan, so each of these scans, they have their different results and what to read them from. Then UDP scan on port 80, um, collecting initial sequence number. You want to collect initial sequence numbers for connections. Every uh, transmission that goes on or transfer of the packet, every packet that moves on has its own initial sequence number. So you can collect the firewalls and timestamps. You want to identify the firewalls, then synchronize scan on port 50 to 60. You can indicate that 8, 50 to 60 S 10.0.0.25 pin push and URG scan FPU 10.0.0.25 scan entire subnet for live host. So if you have a particular subnet 10.0.1.x one, then intercept all traffic containing HTTP signature. HTTP one, SIM flooding a victim. You want to SIM flood the victim. You can use that. Scanning tools, Metasploit, an open source project that provides the infrastructure, content, and tools to perform penetration tests and extensive security auditing. It's an open source project that provides infrastructure, content, and tools to perform penetration tests and extensive security auditing. So you can use this tool to perform penetration tests and extensive security. So also NetScan Tools Pro assists attackers in automatically or manually listing IP version 4, IP version 6 addresses, host names, domain names, and URLs. So mmap has a lot of features. A network administrator and attacker can use this for their specific needs. Network administrators can use mmap for network inventory, managing service upgrade schedules, and monitoring host or service uptime. Attackers use mmap to extract information such as live hosts on the network, open ports, services, application name, and version, type of packet filters, firewalls, MAC details, and that's when we talk about MAC address, that's media access control. So MAC address are physical addresses. These are addresses that are what's the word, add on or imprinted on the network interface cards. So when you have a network interface card is what allows you to connect to a network. So all these older systems, they have this. There's this. I don't know if you don't have it on your computer or your laptop. Many people are using laptop now, but if you have a computer, you see that there's a place where you can plug a network cable RJ45 and it will be blinking. That particular place where it's blinking, or if you go to banks, you can see it. That particular place that is blinking is the network interface card. So, and on that network interface card, you have the uh, what's it called? The MAC address. So, which is unique to every device. No two devices have the same MAC address. So, you can provide MAC details, operating system, along with their versions. So, mmap, there are different tools, but I will let me just go through it. Maybe tomorrow, the first thing I will want to demonstrate is this mmap, but I'll just go through the different things now. Then by tomorrow, I'll be able to show us how it works. Then we can download it and also test it at our own end. So it's a very ubiquitous tool. It does a lot of things. It does a lot of things. I've talked about HPing tool also for scanning, SCMP scan, HCK scan. It's a command line interface. I think, let me see. By the time it's in the, even the mmap is also in the Parrot terminal that we're talking about. So we have tools that you can use to for on your mobile. We have IP scanner for iOS, scans for local area network to determine the identity of all these active machines and internet devices. Allows attackers to perform network scanning activities along with ping and port scans. So if you have this, so but I think there's another one. Yeah, Finch. Can try to download this for Android and also for iOS. If you are connected to um any what's it called, where hotspot or a wireless access point, all other devices that are connected there, it will show you all their details, their MAC address, the maker of the device, everything, even the operating system. You can show you can try and download this thing. I think it should be in the Play Store, Google Play Store. Check iOS. I don't know what the name. I don't use Apple phones. So another tool is network scanner. Also the same thing. It allows attacker to identify active hosts in a range of possible addresses in the network, displays IP addresses, MAC addresses, host name, and vendor details of available devices in the network. It allows attackers to port scan targets with specific port numbers. So we have talked about scanning generally, but I want to talk about host discovery because before you can even talk about it's scanning for ports, it's just like you are talking of you are looking for windows and doors. Before you look for windows and doors, we have to get to a building first. So we have to get to a host. So there are different ways for us to scan, identify active and live systems in the network. Um, we can do there's this address resolution protocol is what resolves IP address to MAC address within a local network. Within a local network, when you want to resolve IP address to a MAC address within a local network, we call it host. We call it a address resolution protocol. So if there are two hosts that want to communicate and they don't know each other's MAC address within a network, so they look for, okay, I want to communicate with this particular host. You now ask for the address, and they now supplies it. So that they can, so MAC address communication is virtually between within a network or say subnet. So, but when you are now communicating over the internet, you use IP address. So MAC address is physical addressing, why IP address is logical addressing. So back to what I was saying. We have a app ping scan. You want to discover a host, you can do app ping scan, UDP ping scan, ICMP ping scan, TCP ping scan, IP protocol ping scan. So under ICMP ping scan, you have ICMP echo ping. Now, I think something like this nature, you want to find out this ICMP echo ping scan. You want to ping, you can ping even Google. Let's say you are on a particular network and you know the IP address of that network. You can ping the device. So this one, it continues to run and run and run. So, but normally if you use Windows, I don't know why this does this, but if you use Windows, it will tell you to send only 4 of these packets, and it will return to you and say, okay, he sent 4 packets and 0 was lost. 0 of the packets was lost. So that's ping. So it shows that the system you are targeting is active, is live. So then timestamp ping, address mask ping. Then under TCP ping scan, you can do TCP scenes ping, TCP ACK ping. Under SNP echo, we have SNP echo ping sweep. Ping sweep. So under all those things we will be doing under mmap. So our packets are sent for discovering all active devices in the IP version 4 range, even though the presence of such devices is hidden by restricted firewalls. There are firewalls that don't want you to know that such devices exist. It's just like a fence. You know, some fences are so high that they don't want you to know what is within a compound. So that's the same way firewalls are. So in most networks, many IP addresses are unused at any given time, especially the private address ranges of the LAN. So when the attackers try to send IP packets such as ICMP echo request to the target, the operating system must determine the hardware destination address. So that's why I said so. The hardware destination address, which is imprinted on the hardware, is the media access control address, which is MAC address. So while you determine the hardware destination address is through a app protocol, which is address resolution protocol. So I think I've explained this. Perhaps ping scan is more efficient and accurate than other host discovery techniques. It can automatically handle app request, retransmission, and timeout. It's useful for system discovery, which may need to scan large address space and all that. So, like this particular address now for mmap, we are targeting this particular address and we are scanning it. And you can see it tells us the host is up. So if it's not up, it will let us know also. So we have UDP scan, UDP ping, UDP response, host is active. So UDP ping scans have the advantage of detecting systems behind firewalls with strict TCP filtering, leaving the UDP traffic forgotten. So many times, like I said, we have TCP and UDP. So many times in firewalls, it's just like when you have a building and it's fenced, it has a gate. Now they now say at the gate that these are the people that are allowed. We don't allow this set of people at all. You understand? So that's the same way the firewall determines. It will tell you it doesn't want this traffic, it doesn't want that traffic. So, but they majorly focus on TCP, which now allows UDP to now function, to go through, to UDP traffic to go through. So this is an example of a UDP ping scan. Then we have ICMP, echo scan. This is an example, SNP. So all in all, why we are trying different aspects are because some of the things may be blocked. May be blocked by the router. May be blocked by the firewall. So well, that's why we try different scans. So if you try a particular scan and it doesn't, it gives you a negative response. So you may not take it as the final answer until you have tried some others, because they may have blocked those particular that particular type of traffic, and it will not allow you to go in. But if you try others, then it will now allow you to go. So I send echo request, I send echo request, reply, reply. So out of you now, this is like doing a ping sweep. You are ping sweeping 10.10.1.9, 10.10.1.11, 10.10.1.13, 10.10.1.22. That's a ping sweep because you are doing more than one IP address at a time. So, and you can see the ones that give you a reply are the ones that are active. So you can use Nmap for that. Look at it. You have 10.10.1.5 to 24. That means it will do 10.10.1.5, 10.10.1.6, 10.10.1.7.8.9.10 up to 24. So it will tell you which of them is up. You can see 10.1.9 host is up, and the MAC address 10.10.1.11 host is up, the MAC address .22 host is up, and so on. So tells you the ones that are up. Then timestamping scan. This one checks for timestamp. Host is all. We are just trying all of them to check. Address mask ping in Zmap also. So it's then TCP SYN. So TCP SYN ping is a host discovery technique for probing different ports to determine if the port is online, check if it encounters any firewall rule sets. In this type of host discovery, an attacker uses Nmap2 to initiate a three-way handshake by sending empty TCP SYN flag. You know, the SYN is used to establish a connection. After receiving the SYN, the target also acknowledges the receipt with an ACK flag. After reception of the ACK flag, the attacker confirms that the target host is active and terminates the connection by sending an RST flag to the target host. Since his or her objection of host discoveries are complete, port 80 is used as the default destination port. A range of ports can be specified, so the probe will perform against each port parallelly. So in Zmap, the PS option is used to perform TCP SYN ping scan. PS option, this is it. PS option, TCP ping scan, ACK ping scan. So pings, PS, okay, ping scan, there's PA, which is ping ACK. That one is ping SYN. Oh, wow. Okay. All right. So we have another tool, Angry IP Scanner, which you can use to target, like you discover when we search on a particular website. ARIN.net, we saw the address range, network range of address. So we can impute that network range in this Angry IP scanner. You can see the IP range option to the left of the screen, and the IP, the other one too, at the left, to the right of the screen. So you put it, then it indicates. So it will search and scan um, all the IP addresses and see which of the system is live. 10.10.1.11, 10.10.1.9, so on. So you can see those ones that are green are the ones. So you can download this also and try Angry IP Scanner. Angry IP Scanner. So it's for ping sweeping. You want to check, and when you say anything ping sweeping, that refers to doing a sweep. When you are doing sweeping, it's not targeted at one particular thing or object or target. It's cross. The cuts are cross, so that means it's not going to be only one IP address or this. Now, the next aspect we are talking about is ports. We have ports, and on each port we have protocols, or what we call protocols, that are running. Now, each um, each protocol, TCP and UDP, they sometimes, while for instance, DNS now, which is 53 domain name server, it has both TCP and UDP ports. But this one, SMTP, which is simple mail transfer, which is for email servers, only has a TCP port. So on the TCP may have a port. It may have a port for a particular service, and UDP may also have the port for that particular service. So I want you to understand that. So, but sometimes only TCP will have it. Mostly TCP has ports for all services, port number for all the services that run. So, for instance, you can see a list of common ports and services. So we have okay, we have Echo, we have different ports, 11, 13, net start. But important, oh, they are important anyway, but you can see them. It's good to, if you can memorize all the sports, at least be familiar with them, because many things will come up when you are doing scanning, um, for you to know what is actually happening. We have 2021 SSH, Telnet 23, SMTP 25, time domain 53, that's domain name service, TFTP 69, trivial file transfer protocol, HTTP, which you normally use to access our World Wide Web, is 80. Then HTTPS www.http. We have 80, we have 81, we have 80, 80, we have 80, 81. Those are HTTP. Anytime you see them, they are HTTP. Then Kerberos 88, POP2, Post Office Protocol, Network Time Protocol 123, Network News Protocol 119, NetBIOS, IMAP, SQL Server, SQLNet, Simple Network Management Protocol 161, Simple Network Management Protocol Trap, CMIP Agent, Internet Relay Chat 190, 194. That's so many. So many. I don't know if they. So we have different port scanning techniques: TCP, UDP, SCTP, SSDP, IP version 6 scanning. So we want to discover ports. We also use Nmap for that. Nmap, the earlier one we used was host discovery, but this one we're talking more about uh, ports, discovery of ports. When we want to do TCP connect or full open scan, one of the most reliable forms of TCP scanning, the operating system TCP connect system calls tries to open a connection to every port of interest in the target machine. If the port is listening, the connect call will result in a successful connection with the host on that particular port. Otherwise, it will return an error message stating that the port is not reachable. So TCP connect can complete a three-way handshake with the target machine. In the TCP three-way handshake, the client signs a SYN packet, which the recipient acknowledges with the SYN plus ACK packet. Then the client acknowledges the SYN plus ACK packet with an ACK packet to complete the connection. Once the handshake is completed, the scanner sends an RST packet to end the connection. If the port is open, it will return RST. It would return, okay, yeah. Okay, if it's open, the attacker sends SYN, the target will return with SYN plus ACK, which is normal. Then this person will send ACK, then he will not terminate it with RST to end the connection. So that's pretty well for, pretty uh, there's no controversy about that. So, but if you send SYN packet and it returns with RST, that means the port is closed. So this is the command from connect or full open scan using Zenmap. STV, ST-ST-V, then the IP address. So the disadvantage of this type of scan, this TCP open scan, is easily detectable and filterable. They usually filter it at the level of the what's it called? At the level um, of the firewall. It's usually filtered. It's usually blocked. It's usually blocked, so it may not work. Then stealth or half open scan, excuse me, involves resetting the TCP connection between the client and the server abruptly before completion of the three-way handshake, hence making the connection half open. You send a single frame with the expectation of a single response. Half open scan partially opens the connection but stops halfway through. The stealth scan is also called a SYN scan because it only sends the SYN packet. This prevents the service from notifying the incoming connection. TCP SYN or half open scanning is stealth method of port scanning. So what do? You send SYN port 80, SYN sub ACK, then RST before the third stuff. So that shows that the port is open. But if you send SYN, particular link in a particular port, and it sends RST, that means the port is closed. So attackers use it to bypass firewall rules and login mechanisms and hide themselves as usual under network traffic. So in Zenmap, you use S. Remember the other One was S, T, then V. So TCP full and open scan, but this one is S, then V. So this um, are for open scan. Then inverse TCP flag scan. You send probe packets with TCP flag, FIN, URG, PSH set or with no flags. When the port is open, the attacker does not get any response from the host. Whereas when the port is closed, you receive the RST packet from the target host. So if it's open, you will not get any response. Or if it is closed, you will get RST or ACK. The inverted technique involves probing in target using half open SYN flag because the closed ports can only send the response back. So according to RFC 793, an RST ACK packet is sent for connection reset. When the host closes a port, attackers take advantage of this feature to send TCP probe packets to each port of the target host with various TCP flag sets. Common flag configuration used for probe packets include FIM probe, Christmas probe. So when you talk about Christmas probe, it has FIN, URG, and PSH. Then no probe with no TCP flag set, then SY stroke ACK probe. So all closed ports will send an RSC response. So this technique is effective with Unix-based system, but it can't work on Windows. Then advantage avoids IDS and login system. Disadvantage requires raw access to network sockets and super user privileges. So we have talked about this in urge or push, no response. That means it's open. Reset means it's not open. So this is Christmas card. SX, iPhone SX, then V. The first one was ST, then V. Second one SS, then this one SX. So we have other sets like TCP stroke ACK probe, TCP reset with non-zero window field. So Windows can result of an open port. So if you do TCP or ACK probe, once you get TCP reset, that means it's open with non-zero window field. It's open, but if it's closed, you get TCP reset with zero window field. Then if it's filtered, you get no response or ICMP unreachable error. Those are TCP or ACK probe. So this also evades IDS. You can only also exploit only older operating systems. So that you see, that's why I was trying to tell us that we need to have some information before we just start performing some things, because there are some things, some kind of probes or attacks that don't work on all systems. So you have to have the background knowledge before you begin to just perform some of these things. So, I think, um, we'll be pausing here for today. So by tomorrow, we'll look at nmap, some of the commands, and also try our hands on some of the tools. I mean, on nmaps, on the different commands. We'll try our hands on some of the different commands. So we'll be stopping here. If you have any question, you can drop it in the chat box for us to take a look at before we wrap up for today. Or maybe you prepare it for tomorrow. A lot of our people seem to have gone off this network. Okay, thank you, Mr. Kenny J. All right, so I hope you have all you got the recordings for the last class. I hope you all got the recordings. As if you didn't get the recording, you can just okay, you got it. All right. Thank you. So tomorrow, by the grace of God, we'll continue.